So looking a little more at some of the things that I ignored on this page. Alright, so this is this page where it's talking about sets of numbers. Looking at this one in particular. So we've got these features of being dense or continuous, and it's noted down here what those mean. Dense means that between any two numbers in the set, there is another number in the set, right? So with integers, this isn't dense because between 2 and 3, there is no other integer. Okay. The rationals, you can do this infinitely, and you get, so between 2 and 3, you can have 2 and 1/18. There you go. There's a rational that's between 2 and 3. And then, you could do 2 and 1/17 trillionth. There you go. Now you've got another one between those, between 2 and 1/18. Or whatever it was I said. I think that's what I said. Anyway. Okay. So we can demonstrate that it's dense, the rationals are dense, and that the integers are not. Okay. But now going back a little bit, the Pythagoreans believed that this property implied via this is the Archimedean property, that there's always something in there between them, that this implied that the rationals were continuous. Okay. Currently, the rationals are not considered to be continuous because you can have things that are not rationals that live between the rationals. Okay. And that kind of fills the gap between rationals and reals. Not really, because you have the algebraics here, which are also not continuous. Because I don't know why it's organized this way. The algebraics should be right here. We'll just ignore that category for the moment. This doesn't really matter. We'll just count the algebraics as effectively the same as the rationals in this regard. But then we currently assume, we axiomatically assume that the reals are continuous with no gaps. Okay. And this is actually coming from, not specifically, but the philosophy underpinning the continuum hypothesis. Right? So we're kind of making the same assumption that the Pythagoreans were about the rationals regarding the reals. And you might say, well, we just define the reals to be everything, so there can't possibly be gaps in there. Okay, but now there's a lot in there that you don't understand anything about. And you don't really know how you get to them or how you can define them properly. Particularly when we live in a world where this nonsense with 0 is occurring. Right? So like here, why are we separating off? We have this real version of 0 here. We have this imaginary 0 here. We have the complex 0 here, which is the combination of the imaginary and the real. But then at the same time, we'll say that 0 is imaginary and real simultaneously. It's defined that way, when it clearly isn't. Why do you have to note it 3 times? And this is completely discounting the possibility of the naturals not including 0, right? Because this is a containment hierarchy going this way. It's a containment hierarchy going this way, right? So the naturals include 0. The imaginary integers include 0. The imaginary rationals include 0. The imaginary algebraics include 0. The imaginary reals include 0. I'm also curious, why does this one have a subscript R to indicate that these are the real algebraics, but this doesn't have a subscript I indicating that these are the imaginary algebraics? And then this whole category here is the algebraics in total. Like, and why isn't there one of these stupid letter designations for the imaginaries? Like, if you notice, there isn't. Naturals, integers, rationals, real algebraics, reals, complex. Here we have a name for the category that spans this from here to here. They are the transcendentals. We have, let's see, yeah, we have a name. It's not really a name, that spans from the rationals to the rest of the reals. The irrationals, it just means not rational, right? So would this be the non-integers here? Would this be the non-reals? No, it's the imaginaries. We have a special word for it. If we have a special word for it, why doesn't it get its own symbol? I don't know, there's so many problems with this that, why should I trust this? Why should I trust this axiom? What does this even mean? Do you even know what this actually means? Because this definition doesn't explain anything. Every sequence that keeps getting closer together will converge to a limit in the set. To me, that does not actually imply that it's continuous with no gaps. What that does, right, as every sequence keeps getting closer together, so like we'll have a sequence of integers. Okay, let's have a sequence of integers from, say, 1 to 7. Okay, as I keep getting closer together, so like 2 and 6, 3 and 5, 4. Hey, look at that. It converged on something. It converged on a limit. What about, okay, so what did I do? Let's do 1 to 2. Okay? 1 to 2. Say that's my set. Okay, that's my sequence. Okay, I'm going to make it go smaller. Oh, now it's just 2. Hey, it converged. Look at that. And it converged to a limit in the set. That doesn't tell me that it's continuous. Okay? So either you're saying it wrong, or you haven't actually thought it through correctly. I strongly suspect they are both true, given how haphazardly the whole rest of this is put together. I don't know. This is a mess. This is just a mess at every level.